Welcome to the world of Venus, our mysterious twin planet. A scorching world of extreme temperatures, crushing atmospheres, and hidden secrets beneath its thick clouds. In this video, we'll uncover the fascinating facts about Venus. Radar is sent from a telescope on Earth to Venus in radio astronomy, and they bounce off Venus. Using this method, we have found that the time required for Venus to rotate once on its own axis is 243 Earth days. It has also been found that Venus rotates in the opposite direction compared to other planets in the inner solar system. Because of that, the sun rises in the west and sets in the east. The duration of one sunrise on Venus to the next sunrise is 118 Earth days. Also, the same part of Venus always faces Earth when it is closest to Earth. Radar images of Venus indicate that there are as many craters as there are on the Moon. This suggests that Venus, like all other objects in the solar system, is very old. The temperature of Venus is about 480 degrees Celsius. Its surface pressure is 90 times that of Earth's atmosphere. A dozen Soviet and American spacecraft have penetrated the dense clouds of Venus and reached its atmosphere. Some of them have survived the harsh conditions there for at least a few hours. Two spacecraft from the Soviet Union's Venera series have captured images of the planet. Through the journey of these spacecraft, we have been able to visit that world. In visible light, what we see on Venus is featureless, pale yellow clouds. However, using ultraviolet radiation, we can understand the complex weather patterns in Venus's upper atmosphere. The wind speed there is approximately 100 meters per second. Venus's atmosphere consists of 96% carbon dioxide. It also contains small amounts of nitrogen, water vapor, argon, and carbon monoxide. The amount of organic molecules there is only 1 in a billion. The clouds of Venus are primarily composed of concentrated sulfuric acid. There are also small amounts of hydrochloric acid and hydrofluoric acid. Even the highest, coldest clouds of Venus are extremely dense. Above the clouds, at an altitude of about 70 kilometers from Venus's surface, the atmosphere is filled with tiny particles. At 60 kilometers, we reach the thick sulfuric acid clouds. As we go lower, we can observe that the cloud particles become larger. In the lower atmosphere, there are traces of pungent sulfur dioxide gas. When it rises to the top of the clouds, ultraviolet radiation breaks it down, and it reacts with water to form sulfuric acid. Sulfuric acid condenses into droplets and falls downward, where the atmospheric heat breaks it down into sulfur dioxide and water. This cyclic process continuously occurs on Venus. It always rains sulfuric acid on Venus, but not a single drop ever reaches the planet's surface. The pungent-smelling sulfur clouds extend up to 45 kilometers above Venus' surface. Below this altitude, the atmosphere becomes dense yet very clear. Due to the extremely high atmospheric pressure, we cannot see Venus' surface. With its intense heat, crushing pressure, and toxic gases, Venus is not the goddess of love but rather an embodiment of hell. Compared to Venus, Earth is truly a paradise. It is now almost certain that the extreme heat on Venus' surface is due to the greenhouse effect. Sunlight passes through Venus' clouds and atmosphere, reaching its surface. The heated surface then radiates the absorbed energy back as infrared radiation instead of visible light. However, the carbon dioxide and water vapor in Venus' atmosphere are entirely opaque to infrared radiation. As a result, the sun's heat gets trapped on Venus, causing its surface temperature to rise. One of the major causes of climate change is the excessive use of fossil fuels. Coal, petroleum, and natural gas are the primary sources of energy we rely on. When these are burned, carbon dioxide is released into the atmosphere. This carbon dioxide accumulates in the atmosphere, intensifying the greenhouse effect and leading to global warming. Due to this, glaciers will melt, and sea levels will rise. Global warming also causes changes in climatic patterns, leading to extreme conditions like droughts and heavy rainfall. Burning coal and petroleum releases air pollutants that harm our health, increasing the risk of respiratory diseases. Acid rain caused by these pollutants damages the environment and infrastructure. The changes happening in nature are also affecting Earth's biodiversity. Many species of plants and animals are becoming extinct, and our forests are being destroyed. If this continues, the survival of life on Earth will become increasingly difficult. Perhaps, due to our actions, Earth may become uninhabitable for us and other living beings. We possess the intelligence and technology to influence the climate of our planet. The question is, how will we use this power? Will we prioritize short-term conveniences without considering Earth's well-being? Or will we take responsibility and protect our planet for future generations? Earth is a small and fragile world. Understanding its significance, we must nurture and preserve it. Reducing the use of fossil fuels and adopting alternative, sustainable energy sources is essential. Only then can we ensure a better future and safeguard our planet for the generations to come.